Magnetic resonance is not LC resonance. Magnetic resonance is resonance between the two coils. The two coils between them appear to have a capacity. So if you like, you could say that the two coils act as capacitor plates between each other. So one being positive, one being negative, or the other way around. So magnetic resonance, it's a crazy phenomena. It's something that you see when the coils L3 and L2 are resonant between each other at the maximum amplitude. The amplitude of the output becomes very high. Before you reach resonance, you might use a little bit of current input, but once you reach resonance, you're going to see current come back at you, sometimes in very large amounts. Okay, LTspice. I'm fairly new, fairly unfamiliar with LTspice, but I do like the program. I just haven't used it enough. What I like about it is you can set up transformers. In this case, we have three coils, L1, L2, and L3. So L2 and L3 are our part and output coils. L3 is set up with a delayed conduction. And what I'm trying to show you here is how delayed conduction can cause the resonance between these two coils. It's if you like, it's a kickoff for the resonance between these two coils. Once these coils reach resonance, all sorts of vibrations, noise, depending obviously how low a frequency you are. If you're very, very high frequency, you wouldn't hear it, possibly even not even feel it, depending on the frequency. Most of my machines that I have built, most of them are low frequency. I showed one in the forum that was about 1200 hertz, 1.2 kilohertz. So most of mine are low frequency. So what we're going to do is we're going to run this very basic simulation and see what we can get out of it. Okay, so we're going to measure this trace here first, and that's the green trace. This trace over here second. That's the blue trace. This trace over here third. Red trace. And this trace over here fourth. Now you can see a definite delay. L3 has a delay in conduction, and I will try and draw a line as accurate as I can. You can see a delay in conduction right there. Okay, from there, whoop, from there, oh, I hate how it does that, to about there. And that's not perfectly accurate, but you sort of get the idea. Okay. So zero cross, blue line is conducting, red line, there's a voltage on it, but we effectively are not conducting yet. The reason we're not conducting is because the MOSFET should be in an off state. Now, I do apologize, I don't know LTspice well enough to be able to completely determine the off state. What we could try and do is maybe this. No, ruined it. So back to here, there, there, and there. Okay. Anyway, back to here. So what we can see is we can see delay conduction in this time here from zero cross. We are waiting this long before the Zener diode conducts, starts to conduct there, and it has a ramp up and then a breakover voltage here. So this, if you like this, it's not a right angle, but it's a perhaps 120 degrees or something there. So this angle here is the turn on time of the Zener diode. This here is where this particular trace turns on. The breakover voltage, so the gate of the MOSFET reaches, it's only 4 volts or 5 volts maybe. So it's a bit hard to say for sure that the MOSFET is definitely turning on. I would have expected a slightly different wave here. But anyway, you get the idea. There is a delay in conduction. Okay, the red line here, we can see that it starts to conduct and it goes flat. So that means that this 200 ohm resistor here is carrying as much current as L3 can provide. Now that would be in a standard transformer, because what we don't see in a normal transformer is a delay in conduction. My thread on the forum, if you go and have a quick look, sorry, wrong. Parallel wire or bifilar coil experiment. Okay, I've been through this before. Any parallel wire that's connected, ends tied, it will carry a current that will be in the same direction all the time, no matter what. And the point of delayed conduction is to try and get the current in one wire equal and opposite to the current in the other wire. So the black wire and the red wire need to have opposite currents rather than parallel currents. That's the whole point of delay conduction. So delay conduction, we see a small delay over here in the circuit. L3 is delayed slightly in time, which we see here. That's the difference in time between zero cross and MOSFET turn on, which is the conduction of the Zener diode. This delay in time is critical. It might need to be very, 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 very short. So you need to play with that distance then to get the best result. Best result will be maximum amplitude, and you always want to aim for the best possible output with the least possible input. The input, when you get a really good machine that runs really good, that you've got right, the input will very likely go negative. Your input will become an output. So the input current will actually be in reverse. You'll see the current coming back at you in greater amounts than what you try to push it out. So delay conduction, that's what it's for. Now I want to make a point in this video of bucking coils. Bucking coils are noisy. When you get two coils, this one here and this one here, and again they're 400 millihenries, 400 millihenries, and this is only 100 millihenries. So when these two coils buck, they're going to carry maximum current. The current will go much, much, much greater than what you would expect, because they're in resonance. Obviously the amplitude increases, magnetic resonance. And like I sort of have pointed out previously in the past, these two coils have a capacitance between them. So each coil acts like a capacitor plate, electrically connected. They have a capacity between them, and as far as I can tell, and again I have worked on this for some time and not been able to solve this riddle. Like I say, there's some fiddling, but as far as I can tell, the inductance here has a difference in capacity, even though the inductance would be the same at that particular point in time. And these two coils have a resonant flip-flop between them, sort of. It's very hard to explain, but that's why I've tried to explain it with the ocean waves, because it's the best possible analogy that I can find. Anyway, they act like capacitors between the two coils. The resonance between them goes up through the roof. Output will very likely become negative depending on how much load you have. But they buck and they make noise and they vibrate and they do all sorts of crazy things. And that was the point of me showing this Floyd Sweet's early machine, generation 2, the big sponge under the bottom. Clearly there was a lot of noise on this machine when it was going. The sponge was to try and dampen the noise, to try and reduce the vibrations. And in the later model, Floyd Sweet actually goes into saying no vibrations. That was in the generation 3 VTA.
No vibrations, absolutely rock steady.
This machine here, there's not much known about the coils in there. I've tried zooming in. You really just can't see it. But at the end of the day, we've got to think about the bucking. The bucking, it's a clear indication of noise. Again here, big sponge again. Now I believe this machine to be approximately 110 watts output, in between 100 and 110. Tom Bearden actually coined this machine, the same machine, as a 6-watt output. I don't know if there was some sort of mix-up or whatever, but these bulbs here, each one of these bulbs is 21 watts each. So I believe it to be around about the 100 watts, roughly. So generation 2, lots of noise, lots of vibration. Coils are bucking in this machine. They have to be bucking. We have already learned that. They have to be bucking to generate a current to support the mass. You've got to remember each electron has a mass, and for each electron in an ampere, which is a huge number, something like 6.24 times 10 to the 18th electrons, roughly, has a mass. So that mass has to be supported. It is a mass that's being guided by the insulation on the wire through a waveguide, and that particular waveguide is the wire, the insulated copper wire inside the machine. And to keep that going, we have to support it. Now, to support it, what we have to do is have an equal and opposite current flowing the opposite way. Now, the equal and opposite current flowing the opposite way is the tertiary coil, which is part net output coils. And that's why the currents have to oppose, they have to buck. So the tertiary coil, when it carries a current, which will be equal and opposite, the current in the tertiary coil will oppose the secondary coil, the first secondary coil, and as a result will support that mass. And we learned in the last video, if we didn't support the mass, we'd see an inductive spike which should go down in a slightly curved manner. It would just fall to zero as quickly as possibly could. You can actually measure the time on the oscilloscope. Anyway, bucking coils, they're completely necessary, as I've just pointed out. Again, parallel wire thread. It's an important thread. I mean, people, if they sort of want to learn this, they sort of need to know what's going on in the thread. We've had some pretty good votes, fully understand the thread. A couple of people not quite sure. But please ask questions. That's what it's all about. If you need to ask questions, then hopefully either I will be able to help or maybe someone else. Again, bifilar coils or parallel wires, if they're connected solid, these two wires will always carry the same current in the same direction in time. There will be no difference in current between these two coils. The current will be the same. Always. It's not going to change. Okay, so visit the forum, come and see what we're up to. We've got some pretty cool things happening. A lot of the guys here are investigating some very cool stuff. I'd like to throw it out there again, if you don't mind. A huge thanks to those who have supported us. This information takes a fair bit of time to get together, a fair bit of time to make sense of, a fair bit of time to try and explain it in the best possible way. So if you could, please support us with a PayPal donation or a Patreon donation. Keeps the wheel spinning, keeps us here, keeps us providing information. And again, I want to throw a huge thanks out there to those that have already donated. Thank you very much. That's fantastic. It makes a big difference. So the thread that I have sort of concentrated on just recently, important delay conduction and bucking coils. That's just what I've just shown. And I really want to iterate the fact that this delay here in time that I've marked out here is very important. Okay, the fact that this coil conducts at a different time to this coil gives the ability for this coil L3 to be the secondary of this coil L2. Okay, when this coil L3 is the secondary to this coil and L2 is the secondary to L1, then that means that L3 must be additive. So the current that's flowing in this coil here will be additive to this coil here. Okay, and the time that it takes for this coil and this coil to slap together give us the great big wave, and I'll play that video now for you.
Nature is so dramatic, isn't it? Very dramatic. Wow. Wow. Like symphony.
Why?
Now it's amazing to see where the best information comes from. Geology is the last place that you'd expect to find good information on conductivity. Conductivity is one of the most important things, and we take it for granted. Let's face it, diodes, MOSFETs, transistors, everything that we use in electronics, everything that we use in chips, IC chips, all that sort of thing, all depends on conductivity. Everything really depends on conductivity. If we don't have any conductivity, we don't have any voltage and therefore current. Now, conductivity is something that not many people look at with any detail, and I didn't at the start. This was something that I sort of fell over on, and conductivity is something that really is required. There's a certain amount of required information that you sort of really need to know to get bucking coils to work. Partnered output coils require conductivity and a delay in time and conductivity in some form or another. So electrical conductivity is a diagnostic physical property that quantifies how easily electrical charges move through given material when subjected to an applied electric field. Now, this is something that science really makes an effort on to confuse people. Now, that's actually not entirely true, because anytime you have a magnetic field, which the requirement is that the magnetic field must change in time, then you can do the same thing. Now, we have learned from Richard Feynman and various other different places that anytime you have a moving magnetic field, there is an associated electric field there every single time the magnetic field moves. So if you have a moving magnetic field, there's an electric field that's associated with that magnetic field. Okay, so back to conductivity. In a mathematical development aid in references describing rocks and fluids. Okay, rocks and fluids, well, that's something you wouldn't sort of expect to read about when you're reading about conductivity. And I'll let you read the rest, because really at this stage we've probably covered the most important bit. And they give you a very good diagram. Okay, so if we were to imagine that this mass is a wire, we have positive charges moving one way and we have negative charges moving the other way. Now you've got to remember, in electromagnetic induction, charges are separated. Okay, so that's the whole point of electromagnetic induction. You see the exact same thing in static electricity when you rub a rubber rod or a glass rod with cat fur or silk or something like that. Charges are separated, so we transfer charge from one point to another point. There's always a difference in charge. The difference in charge causes the voltage. Now, if we can support the current, if we find a method to support the current, which we have, then a current will flow as well. The current will flow for as long as it possibly can, and it's we know from Ohm's law that it's dependent on the voltage. So we have a voltage of say 1 volt, then we should be able to have a current of 1 amp if we have a resistance of 1 ohm. So again, charges in the wire, charges in the copper wire, charges do not pass the, and this is well known, but again, a fact that needs to be pointed out, the insulation on the copper wire, charges do not pass it. Okay, in the last video I showed a small clip, you shall not pass. But that's pretty much what's going on. Okay, if we have a generator, again, the coils coming out to nice terminals, and let's say the terminals were completely insulated. We go to connect our light to the terminals, and because of the insulation, we have no light. We peel off the insulation, and then all of a sudden we connect our light again to the conductor, which is conducting charges, then we have light. So we've got to remember conductor, conducting, and conduction. So delayed conduction in our tertiary coil supports the mass. This is the bucking, but initially the fields must slap together. When the fields slap together, just shown in the last small clip, then we get a much higher voltage, and if we hold the conduction at that point, which we do, then the current will flow in both coils, and the current will be equal and opposite in both coils, and they buck like crazy, which was shown in the previous clip as well. I always try and aim for low voltage. Don't go too high, otherwise it will be very, very dangerous. You could all of a sudden just find the point where it does work, and then all of a sudden things are going to go through the roof. You're going to blow up all your equipment. You very possibly might hurt yourself, so I don't encourage using high voltage. Please use low voltage initially. Be safe, stay safe. So I just want to reiterate, magnetic resonance is very important. It's a resonance between the two output coils. The resonance between the two output coils is almost a capacitive inductance or inductive arrangement, but it's not. There's clearly no capacitor in there unless you count the coils themselves as capacitor plates. I want to give you an example. Unfortunately, the best one I can give you without revealing too much information and getting in trouble, the best one I can give you is actually from Tin Man before he went to the dark side. Tin Man released his Rotary transformer 2015, I think it was. He stumbled across exactly what I was sharing at the time, and he managed to get his coils into magnetic resonance. Magnetic resonance, again, is inductive capacity between each coil. There is an inductive capacity between the two coils, and there is a resonance point where it's found. You can actually go and watch the full videos on my channel. They're actually documented on the forum anyway. But this is an example of magnetic resonance. You can hear it, and you can see the output.
Here's our Rotary transformer version 3. One coil is being used for our generator, the other coil is being used as our bucking coil in the situation. .4 volts across the motor, 0.07 amps. So now our motor drawing 736 odd milliamps, 0.6 volts RMS. Current is 1.645 amps. something is changing in the motor, and like I said, I'm not going to get into that. It's to do with the way these coils are configured now.
So there is a magnetic resonance. Some have tied the magnetic resonance to the electron, which is, or the natural magnetic resonance, 2.8 gigahertz. I posted this post some time back, but I have pointed out many times in the past. The likes of Don Smith talks about magnetic resonance systems all the time. Don Smith's use of magnetic resonance is almost, it's almost like he knew more, but he was not sort of telling people. It's everywhere in the videos, in the documentation, and just in this little blog, or snippet here. There's many references to magnetic resonance, so you can sort of see going through it. It's everywhere. He knew more than what he was telling people. But in saying that, if it wasn't for Don Smith, we probably wouldn't be where we are today. Don Smith shared so much information. It's just not funny, and we can correlate all of his information now because we have machines that show what he was talking about now, and it's talking about the spin. So he's talking about getting electrons to join the party. It's exactly what Floyd Sweet talked about, and Floyd Sweet sort of went into saying that the 9th degree sort of thing, and we all know what that means. So many electrons. So what we're doing is we're putting the electrons up into a higher state of energy, which is normally the magnetic field that they're exposed to, or moving magnetic field that they're exposed to. And at that point, the electrons all get excited, and they start to move. And the more they move, the more you can move them. Once we start having a small flow, we can increase that flow with our machines with what we're doing. And we're basically pumping the electrons. All we're doing is we're firing the electrons down the wire, exactly the same as what we've shown in the magnetic railgun experiment in the little video. Now I just want to throw it out there. Those people that can afford it, we share huge amounts of information. The videos that we're putting out contain lots of information, lots of explanations to try and help people understand what we're trying to share. We have collected more information on this particular subject than anybody else on the internet. There's not another forum out there that contains this much information. We are the House of Energy, and our forum, you can come and be part of something better. We're all working towards the same goal. I'm trying to share as much information as I can to try and help people reach their goal. So please, if you can, please support us. It really helps keep the wheels spinning. We have mostly self-funded this website, this effort. I've been self-funded for the last 20, 30 or so years, whatever it's been, 27 years or whatever it's been. So please help fund us. The experiments we've done have been massive. We have information that we're sharing that's unique. So if you wouldn't mind, just a small donation. The more people that donate, the better off we'll be, the easier it will be to keep the wheels spinning, keep the website up and all that sort of thing. So thank you very much. Just want to throw a huge thanks out to those people that have already helped us out. I really appreciate it. Thank you very much. That money will go towards keeping the website up, running, solid, and everything else. So thank you very much. Again, it's about the people. If we can do all this together, then there's no stopping us. We will be unstoppable. Thanks again. It's just a short video. Just want to reiterate a few points and try to make things a little bit clearer for everybody. Thank you.